Welcome. So in this video, we'll be answering this question before us. It says, a builder has 90 meters of timber to make a frame. The shape and dimensions in meters of the frame are shown below. What we need to do is find an expression for y in terms of x. So let's look at the diagram that we've been given here. And as you can see, we have a y length here and a y length here. Now, if this is y and this is 2y, we can also deduce that this right here is going to be 3y because y plus 2y is 3y. So let's just put that in there. So this right here is going to be 3y. And we can do a similar thing for our x. So here, this length is 2x. This length is x. X plus 2x is 3x. So this side right here is going to be 3x. So let's write that in as well. Perfect. Having now done that, we know that if we were to add up all these sides, it's going to be 90 meters. So let's just write that down. So we know that 90, let me zoom in here, it's going to be 90 is equal to, now let's get this right, I have y plus 2y, that's 3y, 3y plus 3y is 6y, and then I also have 3x plus x plus 2x, that is 6x. Now, let's read this carefully. It says, find an expression for y in terms of x, So that means I want to get y by itself. So what I'm going to do is I'm going to subtract 6x from both sides. And that's going to leave me with this. And then I'm going to divide both sides by 6. 90 divided by 6 is 15, minus x is equal to y. So therefore, my answer is going to be y is equal to 15 minus x. So as you can see, I have written an expression for y in terms of x. And that's what we have to do for the first one there. Perfect. If we zoom out here for a second, you can see it's worth 1 mark. So we're just getting 1 mark for the answer there. Okay, let's now keep on moving and come to part B here, which says, show that the area A in meters squared inside the frame is given by this right here. Okay, so it's a show that question. So that means our final answer has to be this. We can't really use this to get our answer. We have to get there ourselves. Okay, so what we're going to do is we're going to come up here and we're going to find the area of this thing. So if I was just to cut this off for a second, I could say that the area of this portion is just going to be x times y, right? X times y. So it's going to be xy. And the area of this portion right here is going to be 3y times 2x. 3y times 2x, which is going to be equal to 6xy. If I now was to add this and this together, I'm going to get the area of the total thing. So I'm going to come here and I'm going to say that my area is equal to 6xy plus xy. So all I've done there is I've taken xy and 6xy and added them together. Now you might be wondering to yourself, well, that doesn't look like what we were given here. And the reason for that is, as you can see here, this is a in terms of x, just x. There are no y's here, but we have y's here. So how can I get rid of these y's? Well, I know that y is equal to this. So I can say, let y equal 15 minus x. So let's now do that. So I'm now going to rewrite this as a is equal to 6x, and then put 15 minus x here, plus x, 15 minus x. Then once I've done that, I'm going to get 6x times 15, which is going to be 90x, and then 6x times negative x, which is negative 6x squared, plus 15x minus x squared. Let's now gather our like terms together. So a is going to be equal to 90x plus 15x, which is going to be 105x. And then negative 6x squared minus x squared is going to be minus 7x squared. And as you can see now, this is the same as this, 105x minus 7x squared. So 2 marks, so 1 mark for the working, 1 mark for our final answer, showing that this is the same as that. Perfect. Let's now keep on going. It's saying now, part C, write down the domain of the function found in part B. So let's just remind ourselves of what we found in part B. We found that a is equal to 105x minus 7x squared. Now, we have to find the domain of this thing. So what we're going to do is, we're going to treat this as a function. So we're going to write a of x is equal to 105x minus 7x squared. And we also know that because we're dealing with area, it always has to be greater than 0. So we know that a of x has to be greater than 0 because, you can't have negative area. The next thing that I would do here is just kind of help us visually to understand what we're dealing with, is to give our graph a sketch. And remember, we've got our trusty CAS calculator here. So let's come over here. Let's come here and let's define our function. So we have a of x, control this button, 105x minus 7x squared. Perfect. And now what I'm going to do is I'm going to graph this thing. So I'm going to come to my graphs and then I'm going to put a of x. As you can see, it's bolded because I've defined it. And now, oh, that's not too good. Let's go menu, let's go window zoom, let's go fit. And that's okay, but let's see if we can just make that a bit nicer again. Let's go menu, let's go window zoom, let's go box, and let's just put a box around what we're after. So we're after just that there. Let's go escape to get rid of that. So as you can see, this is what we're dealing with. And it's quite clear that if we know one of the restrictions that we're dealing with is that a of x has to be greater than 0, then our domain is simply going to be from here, so from 0 all the way to this point here. So if I was to go menu, analyze graph, and just find my zeros here, this is going to be 0, menu, analyze graph, and then find my zeros again. There it is. So this is going to be 15. So based on that, what I can say is that my domain is going to be from 0 to 15, because that's the only place where I'm going to get positive outputs. And I know that my area has to be positive. I can't have negative area. So that means what I'm going to do now is I'm going to come here and I'm going to write domain is x is an element of 0 to 15, but I'm not going to include 0 or 15. I'm just going to leave it like that. Perfect. Now, if you were struggling to find these two and you're thinking in terms of not graphing it, I think graphing it is the easiest way. But if you just wanted to provide a bit more working out, I mean, it's worth 2 marks. What you could do is we could factorize this. And by factorizing it, we're going to clearly see what our x-intercepts would be. So to do that, you just go menu, algebra, and you're going to see that factor thing. And then you can just chuck in a of x like that. And you're going to get this out right here. So as you can see, whoops, let me just put this over here. And let me just move this down a bit. So we're just providing maximal working just to ensure we're getting the full marks here. We could say that a of x is equal to negative 7x, x minus 15. So that means x would be equal to 0 and x would be equal to 15. And hopefully that would be enough working for everything we have to prove here. So we're proving here that I have an x-intercept occurring at 0 and then another one at 15 by utilizing this factor, this factorized form here. Perfect. Let's keep on moving now. So it says on the set of axes below, sketch the graph of A against X, indicate clearly on the graph the turning point and the endpoints. So the turning point and the endpoints. So this is where we're going to utilize the graph that we used over here. Now we have to find analyze graph, maximum. Perfect. So as you can see here, it's 7.5 and then 394. That's my turning point here, and it clearly tells me that I need to indicate what my turning point and my endpoints are. Now this is where you have to be really careful. It's telling me that it's 394, but if I go menu, if I go settings, and do you see how I'm on float 3? If I was to give this a greater float and go OK, all of a sudden I see more decimal points here. And you need to make sure that you don't have too few of a float, that you're not getting the correct amount of decimals out. So in that case, we don't want it rounding. We want to show this as our final answer right here. So it's 393.75. So now let's give this thing a sketch to the best of our ability. So it's going to look like that. This is going to be 15 and 0. This is going to be 0 and 0. And this turning point right here is going to be, now what was it, 7.5. 7.5, 393.75, like that. That is my turning point. All right, so we've got our two endpoints and we've got our turning point. That's everything we need for that, so very good. We can keep moving on from doing that. Okay, so now it says, hence find the maximum area of the frame. So our maximum area is just going to be our turning point. So remember, our y-axis here represents our area. The x-axis represents the x of value in this case, because remember, it was x and y that we were dealing with. So it's going to be 393.75 is our maximum area. So let's now write that down. So we would say the max area is 393.75 meters squared. And now it says we need to find the values of x and y for which this occurs. So the values of x and y for which the maximum occurs. Well, I can immediately tell you the x value for which it occurs is going to be 7.5. But how are we going to figure out what the y value is going to be? Well, if we just scroll back here to our first question, we figured out that y is equal to 15 minus x. So if I was to come here now, I know that y is equal to 15 minus x, which means I would go 15 minus 7.5, which means y is going to equal 7.5, because 15 minus 7.5 is 7.5. So that means x is going to be equal to 7.5, and we could put meters there, and y is going to be equal to 7.5 meters as well. Perfect. Well done. All right, let's keep on chugging along. Is this the last part? Wow, this is the last part. Okay, so here it says, because of a shortage of cement, which will be poured into the frame, the area inside the frame is to be restricted to 252 meters squared. Write down two possible values for x and y for which will fulfill this requirement. So now we have this restriction that the area has to be 252 meters squared, and there are two possible ways in which this could occur, and we need to find the x and y values that correspond to them. What I would immediately want to do is come to my graph and simply come here, bring up, hit tab, bring this up and type in 252. And now what we're going to see is the two places in which the area would be 252. So menu, analyze graph, and we can find where these intersect. So it's going to be here. Menu, analyze, intersection, it's going to be here. Okay, so now what we're going to do is we've found the x values for which I am going to get an area of 252. It's going to be 3 and it's going to be 12. But now I need to provide enough working here to demonstrate what I've done. So what I'm going to do is, what have I done here? I have taken 252 and I have set it equal to 105x minus 7x squared. So when setting these extended response questions in which you have the CAS, there is no need now for you to do any algebra to solve this, but rather what you're simply going to do is you're going to write down that we're going to solve for our x value. And by writing that, it's showing that that's what we're doing. So we're solving for x, and we're going to find out that x is equal to 3 and x is equal to 12. So do you see how I'm kind of writing down what I'm doing? But great, luckily we have our CAS, so we don't have to do it by hand, but I'm still writing down that, hey, I've set this equal to this, and then once I've done that, I'm solving it for x, in which I get this, and then after I've done that, I'm going to find out what my y is going to be. Remember, y is 15 minus x, y is 15 minus x, so that means in this case, it will be y equals 15 minus 3, and over here, it will be y is equal to 15 minus 12, which means y is equal to 12, and over here, this will be y is equal to 3. So I would just want to write this out nice and clearly at the end. So it's going to be x equals 3, y equals 12, or, that's the ugliest or I've ever seen, or it will be x equals 12 and y equals 3. Those are our answers. Perfect. And that now brings us to the end. So hopefully you feel comfortable with doing this. getting all these answers, making sure you're providing enough working to get all the marks, but realizing that we don't have to do much by hand because we have our CAS with us. So hopefully you found this useful. And with that, I'll end it here, and I will see you in the next video.